Okay, so now exercise 9 again. Then after that, we're gonna move to testable questions. Okay, now in this exercise, we are expected to understand end positioning monitoring. And I normally don't say you are expected to understand in a test. I just tell you, you need to deal with, and probably I would say, I want you to, yes, sir. I'll tell you that you must do end retracted, or you must do end extended. Extended end position. The reason why it's changing from HMI to TP is because it realized that the computer is actually a TP. All right. So, as I was saying, I always ask you, like I'm direct on my questions. I'll tell you that you must sense the end retracted or the extended end position. I will always tell you that. Okay? And then, so the type of end positioning monitoring is also very critical. I did show you the sensors that are wrapped around the cylinder, which are proximity sensors. And I did also show you the other ones that works outside the cylinder, meaning that as the cylinder extends, then they interact with the cylinder, such as the roller levers and stuff like that. So although on my list of sensors, I do have sensors that do not necessarily sense they are also proximity sensors, but they're not wrapped around the cylinder. I do have those type of sensors as well. So I think I can maybe show you one of them, and we fetch one. Okay, let me then turn on the camera quickly. So these are approximate sensors, proximity sensors. So this one over here, I'm forgetting them. I feel like it's a metallic sensor. It only sends metallic stuff, And over here, it's optical sensor. So, oh God, always forget that. Sorry, I must grab like that. Okay, so yeah, this one is a proximity sensor, metallic sensor. It is very vital for you guys to understand the type of sensors as you go to industry, whereby they will tell you the product that must pass there, it must be either or plastic, box, metal, stuff like that. Then you take a proximity sensor that can sense anything that passes next to it. So a preferred sensor for all sorts of objects passing, it will be the one for optical. So it shoots a light area, yeah? A light beam on it. Then anything that cuts that light, it picks it up. Yeah? And also it is adjustable here. The distance is adjustable. Most sensors are normally adjustable manually on them, and it means if the sensor is intelligent to do that. Others, they come also with a digital screen, they cost an arm and a leg. But if you have a standard sensor, which is a analog sensor, it will come at a lower price, but you'll have to configure it on the PLC. So you measure the height on the PLC. On this one, you measure it manually on this. Not unless also it has an override on the PLC. Some sensors will be manual when you look at them physically, but as soon as you put them on the PLC, you'll get that ability to change the sensing capabilities. Okay, so as I was saying, this one is metallic, and then this one is optical. It measures based on distance, so it will be good to sense objects moving on a conveyor belt of different material. Then we have the ones for magnetic, for heat, for pressure, and all sorts of stuff. Most of my stuff were delayed. I was supposed to introduce you to a mixture of PLC and series pumps, series parallel pumps, but yeah, some components are delayed. For the first time, our procurement it's very slow in a very bad way. Both things January, they're still not yet delivered, and prices have changed. Imagine. So you guys going to deal with procurement. Keep that in mind. You need to entice yourself into the buying, selling system, because you can become a sales engineer whereby you need to understand specifications and stuff like that. And you can also be a person who's required to be buying stuff, like maybe a maintenance engineer. You need to spec pumps and stuff like that. I believe there must be handbooks that can guide you. You don't necessarily always have to write formulas down to determine the size of the pump, the voltage, and stuff like that. They don't teach handbooks at school, but when you get to industry, if you're lucky enough, you might get somebody who's honest with you and tell you you need a handbook that specializes in pumps, that specializes in solenoids, that specializes in whatever things that you are working with. So if you're lucky enough, I would encourage you getting them now, because you guys are mostly likely to work whereby you are required to spec. So let's see. I want to share back the screen. Okay. Right. So bottles need to be diverted in groups of 3 from one conveyor to another by means of a diverter. After being switched on, remember, we always put a storyline that sometimes is not necessary. I told you that. We hide relevant or critical information in the story. Some, like with a comprehensive test in English, you write a long story and then you need to pick up the right words from that comprehensive essay or something like that. After being switched on, the system should run continuously. Yeah? So this is what is critical. The system must run continuously. Although I fail to understand why wouldn't they say the circuitry must run continuously, the electrical part. So on industry, the bishop on industry, when you're developing something, information is vague. But once you are working like as a maintenance engineer, they tend to tell you what they want and how they want it. So most of the time, you are most likely to work with closed-ended problems, unlike open-ended problems. I'm sure you know about the level of complexity of problems. Once it's open, it means that you are most likely to do trial and error and stuff like that. But once it's closed, it means that everything is specific and you are speaking according to the requirements stipulated in what they call user requirements, something like that. So it should not be switched off until a stop signal is generated. I don't like saying a stop signal is generated. I just prefer saying the push button, stop push button is actuated or is pressed. I don't understand. You don't necessarily generate the signal when you press a normally closed button. You are cutting the signal. You're not generating it. So I maybe I'm not an electrical engineer. Maybe they can resonate to this, but I don't find it sounding very clear. Okay, the sequence is started by pressing a push button, right? And then if three bottles are present, the diverging cylinder piston rod is advanced. Okay? The bottles are diverted and transported to a second conveyor belt. Okay, so this is a diverter, so it pushes off products from one conveyor belt to another. So once there are three, this doesn't look like a conveyor belt, no? But okay, it's fine. So if we were doing this scenario on factory, oh, trust me, you were gonna actuate even the mechanism responsible for sensing whether the products are there or not. You will see. Actually, the next step is we'll be doing it on factory. Oh, we'll be using personal laptops, computers that are not on a network because we don't have an official license that we can use. So, but it will be interesting. I want you to learn that software. I want you to have that software to keep it and to use it even in the future. You will license it when you have money because I know it's very expensive, but it's a software that I need you to have it always. It will help you. It can work with almost any PLC that is there in the market. And you guys are mostly likely, like students that keep on coming back to me from mechanical wanting to learn PLCs. So you are mostly likely to find yourself needing to understand PLCs. And Factory.io is one software I'm confident it can teach you PLC to the highest level of what they call vertical integration from the automation hierarchy. So that concept also is very important. You need to Google it when you have time. The automation hierarchy or automation pyramid are the subsequent systems that are there. If I had time invested in me to teach you all these, I would honestly. But yeah, I don't. So now, obviously, for this mechanism, sensing mechanism, they want us to use a proximity switch. As you can see from the diagram, you can't use other type of sensors. You need the one that is embedded on the cylinders. And also, the other beauty about Factory.io, once we say proximity switch, it will be there on the cylinder. It's not like here, you can't see it, but you must guess that it's there. Okay? And then we need to be able to do the end monitoring, the end position monitoring of the pneumatic cylinder, okay? And then you complete the circuitry. So I think I might ask you one end sensing position and one speed control, just to test you nicely. The test will be basic, but yeah, you must expect either to sense the end positioning, the retracted end positioning, or the extended end positioning, but one of them. I think it will be much more interesting so that you can, because if I give you both, you're going to put both of them there, and then you get 100. And if I say with the control, the one-way control, if I say both, you also going to check. But when I say I want you to reduce the speed of retraction, then I know that the positioning of that one-way valve is critical. And for this exercise, I will say for instead, for this exercise, we'll say we want to reduce the speed of extending. You know why? If you extend very fast, what will happen? They will tilt, okay? And you don't want that. But you can retract very fast. So that's our scenario. So that's how even my test, I create these scenarios because I can test them either on the workbench or on other softwares because this is related. Actually, it is possible to connect our PLC software to this. I have a long video from where I was attending a webinar from Festo. They were showing us on how to do it. And then the software that enables that is this one, EZOPC. Then you turn on codices, you turn on the software, and then you turn on fluid sim, and you will send signals from PLC to fluid sim, and you see stuff moving. It's very critical for you to understand that most of the time, whenever you deal with pneumatics, they might be controlled by PLC. Actually, let's put it in perspective. They are always controlled by PLC. But the basic circuitries are also important. But you need to understand that when there's a push button, we put a sensor, we connect it to a PLC, and the PLC does the controlling. And the next part, the next steps will be based on the PLC. Okay? So now we know our story. Let's now build something. We have this, okay, and okay, the other group, they are teaching basic pneumatics, so yeah, we have everything open there. We did talk about the 5-2-way double pilot again, or I always test that one. Is this one? 5-2-way. Oh, that's the one. Okay, and I always mentioned this one, service unit, and that one, which is pressure, no, which is the compressor. Okay, and then I said it must what? Okay. You are lucky, guys. Okay. Be prepared slightly. Yeah? I normally don't just throw you on troubleshooting type of exercises, but you need to understand. Yeah? I'm going to create a problem. You need to spot it, yeah? And you need to know what is the solution. Okay? So now, the advancing is the one that is controlled. Okay? 270. No, not this. This one. 270. Okay? So now, I will deliberately put it here. I don't know where it must go. Okay? And remember, I did talk about the fact that you can simulate before you finish the circuitry. You can, like I am doing now. So I can see there's a problem. Ne? Problem number one. How do we solve it? Where it is? Listen, no? You see here, it tells you. So I just need to drag it like that. Start again. You see, I just moved it slightly so that this is exhaust terminal. These two, they are called exhaust terminal. Their job is to exhaust air. At the current moment, there is pressure built up on this side. Again, there's pressure built up on this phase. Let's say, yeah, let's put it on phase. There's a normal phase and then there's an actuated phase. On the normal phase, we did say that on the one with the spring, the cylinder is held to its retracted end position by what? By the spring again. This one is by what? By this pressure here, by the pneumatic. Ne? So there's pressure here. So if I regulate here, what will happen? What will happen? Will it extend slowly? It will extend fast and retract. I like it. See now? So now it's extending fast. So now there's a vacuum this side, not necessarily, should I say, let's say pressure, let me not use terms that I don't understand. There's pressure this side. Now, this pressure, it's going to be downward. So these guys are not stupid when they're doing this 270 thing and whatever. So they want us to only regulate the pressure that we're going to dump, so that we always have full extension and full retraction. Because now, once we retract, yeah, there is pressure this side. It needs to be full pressure. And then we can only, because this one we are dumping it at 5 there, we can only regulate what we're going to dump. It's safer like that, and it guarantees full extension, yeah, and full retraction. So that's why for this one we are incorrect in a way. We're only regulating the retraction, not the extension. So I believe now I have clearly explained it.
So, sir, if you are regulating the extension, that means the shower valve is going to be on the other side.
On the other side, yes.
And then there will be nothing
on the yes, because we always need full air to push it out. Because if you're gonna regulate from the other side, you are not going to push it successfully. Then what will happen is, where is that question? Let me get my textbook. These things they misbehave every time we have to. So this won't retract fully. And once it doesn't retract fully, what will happen with the products? They'll get jammed. Does it make sense now? We need a full retraction and a full extension. Because if we don't fully extend, if it happens that this also has a conveyor, I don't know why they call it a conveyor, it doesn't look like a conveyor, but we'll call it a conveyor. If it happens that you didn't push enough for them to get to that roller conveyor belt, to the belt, then the belt won't pick up those products. Then it's going to still create a jam when the next products are coming. So that's why you need full extension. And sometimes you want to separate them, because if this is a conveyor belt and you are saying every 3 seconds, like the product needs to leave some gap. Yeah? So maybe let's say we are doing Fanta and then you're doing Coke. Now they're gonna have a gap if indeed you are fully extending and retracting. But if you are not, now you're gonna have them mixed up together now, and maybe you don't want that. Or maybe your picking and place system that is going to palletize for you will not be able to comfortably pick them up because of this no more gap. Although in other scenarios, they do permit you to do half extension, but you need to be aware of your doings. Unlike to do things involuntarily, because that is dangerous in a way. That's why you find hands getting stuck in between machines. Because once it gets stuck, there is pressure either in the extending or in the retraction. Then you don't know. Then there's something jammed, and then you put your hand in the wrong side, then it clip you. Because the end part here, this end part can be anything. It can be even a razor blade. You understand? So then you are most likely to be cut if you are not doing according to what is required. I hope you remember this in the future. So now, okay. Look something. When I start, the ball it jumps up. Let me do this to show you that we don't regulate in reverse. So here the ball jump up. So to show you that we need the pressure to contain this cylinder. If the cylinder was like that, this is a system, what you call of simulation. In real life, the cylinder was going to jump back and retract. That's why you need to understand these systems. And now you have a hand. Remember, the cylinders, they vary in size, guys. Yes, mine are portable and like this size. Go to industry, you'll get surprised. You'll get a cylinder as tall as you, and you don't want mistakes. So you need to know a 5-2-way valve will always retract this thing automatically. And if you know the kind of company you're going to, take a short course on Udemy just to refresh up, and also follow these videos because they will be there on my YouTube permanently. So now we know that we are regulating the expansion force and not the retracting force. Okay, so to move stuff gently. Okay, they have other pressures that they can use, but I think the other complicated stuff we can DIY, and Udemy is there for that. Otherwise, we don't have the entire year to cover these concepts. So now let's build now the system. Oh, sorry. Copy paste. As you all know, if you can only rotate it once it's, you see when I click on it, there's a click here and there's a click for it to be, that's when you can only rotate it if it's highlighted entirely, or it has a border on it. Then you do the 180 so that you can be able to connect directly there. Okay, copy paste. Hey, my borderline is far today. What's happening? But still, I feel like it's far. Oh, Control Z doesn't work here. Okay, you realize that. Oh, I'm close to the border, actually. Okay. There will be a penalty, obviously, for crossing the border, but do not stress much about it. I have to penalize you, but do not stress too much about it. I know some students, because you just don't practice, you end up now, when you want to now write a test, you wanna, make sure you fill up the space and stuff like that. You are allowed to do that, but you want to get a penalty once you cross the border. And I don't want you to stress too much about it, because once you make mistakes, I always say this, it's difficult to rectify them properly. So now let's go back to this. This is our normally open switch, okay? But it's different to the valve. Where on the valve, when it is normal, there is a flow of something. Okay, we know that. So now we're gonna choose this one. Okay, I want to use a dented push button. Yeah? This is a proper emergency switch once it's like this. It's a proper emergency switch. Okay? And then, from the look of things, you can see we have an end series here. This is an end gate. Yeah? So it's going to work like this. Once this is connected, you see, it's an end gate. You see that? So they are in series when they're like this. Both of them need to be connected. The other one is normally connected, that's why it's like that. Okay? Then now, once we want to latch it, we then put a changeover switch here. You need to put a changeover there to be, and then you connect there. And then the changeover is going to have the same name as the relay. So maybe relay 0 here, R0. Relay 0 and relay 0. Okay? Now when you connect, the system can latch. I am wondering if you can physically connect this. But no, it does work when you connect them here and do the relay stuff. Yeah, it does. It does work. But what you need to be using a relay. You can latch on the relay. That's why they normally call it a latching relay. If you go to my old software called Logosoft, this connection actually is called latching relay. It is a physical component. You can buy it actually. So now, when we break it, do you see now? It remains closed. Okay? This is my safety switch. You know why I prefer this? Because you can connect and nothing will happen. You see that? That's why I like it like this. So this is for your safety net. Always use this type of sensor. Let's see if we can. This is stupid. Your emergency button, guys. Let's go to Google quickly. EMG button. Yeah, something like this. When you press it, it holds in, it latches in. It's very critical, so that the system doesn't, by miracle, run or by bad luck. You are not acting a final destination, so you don't want such events. Okay, so now the system actually would be granted complete, but they want us to sense the both retracted and extended end position, right? So now relay number 2. I'm most likely to ask you the proximity sensor, guys. Honestly speaking. So this one, proximity, I won't write it in full. I think it's just a long thing to write. So P0, proximity. P stands for proximity. P0. So then this one is R1. Okay? So we always start at 0. This one is obvious. This one you must obviously say PB start. It always makes sense to call it in full. Start, then EMG, emergency, stop button. Okay? Then now we have this. Want now to put a ruler. Remember the function of a ruler. In real life, you use a tape measure to measure the fully extended, and then you confirm it is 100 or whatsoever. Actually, you just put a sensor on there, on that, because remember on the cylinder body near the cover, once you move the sensor on top of it, once you put it at the end, it means that it's going to do the maybe the extended end position. When you put it at the back, it will do the retracted end position. On the cylinder body, it's easier to do this. But once you're going outside now, once we use these sensors, you will definitely have to use a measuring tape to confirm the distance in between the cylinder and the sensor. You will do it manually. But because we're doing it electronically, we are forced to come here and to say P0 is positioned at position 0, 0. And then it becomes active. It does tell you that at position 0, even if you look at the ruler there, it does show you we are at 0, 0. Yeah, you see, P0 is equal to 0 millimeters. You see that? It does tell you the positioning. I like that. Didn't know that it does do that. So now here, the circuitry inside here has changed. If you can look at that, the circuitry inside here has changed. Initially, it was not actuated. Now it's actuated. Let's change this maybe to 1, and then you see the circuit there, the magnet. So this is a magnet. It's called a reed switch, aka magnetic sensor. So it does tell you that it is sensing the magnet inside there. I think this one is a sensor. It senses the magnet there. Then it closes the circuit. Let's change it back to P0. Then it senses the magnet and it does activate. Even before we press play, it knows that we are actuated. All right? Then, moving along, we go to 2 changeover switches. 2 changeovers, like that. Now we are completing the shandies. Hey, I don't want to say shandies now. I'm misbehaving.
So how do you know that you want
they want us to sense. Yeah. Remember this. First of all, this indirect actuation. So you know, with indirect actuation, in order for us to actuate the solenoid, we will be forced to. Okay, let me just do it fast, and explain what I do. We will be forced to connect to say R0. So that will come there and actuate sol, sol 0, sol underscore 0. What is my home boy? So, okay, let's do this. So now the system was going to be like this. Ignore this part. Ignore the P0. Let's only consider the start button and R0. When I turn it on, you see there, and it extends. You see now. But now we said we are concerned about the end monitoring. So we need to, the end to end. We need to firstly, this thing's misbehaving. What's wrong? We need to firstly measure the end retracted. And then lastly, the extended end, end extended, something like that. Extended end, yeah. So, guys. So practice so that your circuit can always fit into your page. It can only happen through practice. Don't practice in a test, you will trouble. Trust me. Will make millions. There's difficulty. There's nothing difficult in mutation. It's just the pressure. We put you on the open, and you feel pressure, then you explode. I used to fail myself because of that. But once I started doing this calm and relaxed, started understanding that. And we repeat it for 10 years, obviously you eventually master it. Industry normally you repeat stuff for a very long time. That's why you end up being called an expert. And some people, if they see value in what you do, they then say, man, how much do you want? 600K per annum. That's how you put value onto yourself by doing one thing for a long time to a point that you become an expert. So now R1 is active because of P0. I think you know that P0 was activated. That's why P0 it's now how can I put it? It's now red. And if you can notice also, it does show the location of P0 there. That it's at the end position. Let's play around. I want to put 100%, 100 at 100. Let's see what will happen. These are the stuff that you guys must explore yourselves, but I am exploring with you. So you see now the trick. The P has moved to the end extended position. And initially, when I put it at 0, it goes back to the retracted position. And extended and retracted. Yeah. So then you need to test these things, guys. The reason why I love softwares you can take home is for you to test, to explore. Intelligence and creativity is only triggered when you can do things by yourself in the comfort of your own home. Let no one tell you opposite of that, unless they're against your progress in life. Okay, so now we are fully sure that we can extend. Yeah? And we need to return. We can return either by a push button or by a sense. You get it? So, and you can also do them to be parallel, the retraction. You can put the push button and you can put a sensor and they will work. Let's do it in that way. But remember, we did an OR. This is an OR circuit here. This section here is an OR. We're going to retract here with an OR, either push button or a sensor. But unfortunately, the sensor will always take precise, but it's fine. We'll find a way to maneuver it. Guys, I don't encourage copying and pasting. I know the memory of the student. Under a test, I don't encourage it. So I will tip you guys. I don't encourage copying and pasting because you guys tend to forget that we need to change this to P1. If you trust yourself, okay. Obviously, some people practice and they take notes. They know this stuff. They always remind themselves. If you do, if you are confident, I will never be the obstacle of your confidence. Do it. And then how is this going to be an OR gate if it's already connected like this? This one. Guys. This one might not work, but I'll put it on the changeover section because when I look at it here, I don't really see where I can possibly connect, or I can just yeah, I can tap. Okay, let me try. Please note this, whatever that we're doing right now, the complicatedness of this. So we start watching that. This push button won't have a name for now. And which no, you can't connect from the 24 volt. You must connect to the yes, it must go like that. I'm at the borderline, that's why I'm coming back. Okay? So this or that. This is the OR gate. That's how it goes in. I'm not 100% sure about what I'm doing. Just like exploring. R1. Oh no, you see that? I'm misbehaving. What is this R? R2. Sol 2. Sol 1. So underscore 1. Start. Oh, there are no errors. We are allowed to zoom in, zoom out, guys. Let's see. The sensor. Q1. There. Q1. It is. Then R2, sol 1. Yeah, I think it is. So since while this system is, oh yeah, I think it will work. All right. So it extends. This one activates. Then it goes back. So this is what it will do. So in order to, let's say you have products coming at a certain rate, you can put a delay timer for the extension. So it will come at it will retract at full speed, and then it will wait for the product to come in, and then it will start to do this. You put a delay timer for the system. That will be explored nicely under the PLCs. So let's test the push button now. You see, the push button can turn it at any point, and it can even keep it there actually. So yeah, the push button does work, but it's something that I was just exploring out of curiosity. And this also can be created to be an end series. To say you cannot come back until I press the push button, although it has confirmed that it's fully extended. How is that? It's like this now. This comes there, okay. Yay. Now, you can highlight everything if you are brave and move. I'm not sure. The borderline seems to be but you no longer gonna have the view. I understand, but yeah. I mean, teaching possibilities. Those who are not confident about messing up with the borderline, they can do it underneath. Me, I will always know what is what, but I'm sure if we zoom out, it's always there. So, yeah, we are free to do this like this, guys. Although it's gonna give me headache, for the sake of the ability to move around, you are free to do this. Connect and connect. Okay? So now, this one is R3, okay? Right. Obviously, if we need to copy, there's a problem I want to create, uh, but it's fine. I think there is a problem that can occur. Hopefully, it will show here. All right. Start. All right. Yeah, this is a problem. No. It is not a problem. R3 is here. R3. Okay. Right. Let's extend. It connects like that. Okay. I forgot how to treat that problem, but I know there was at some point a problem when you don't do the sequencing properly of the relays. Maybe you will discover it as you are practicing. So now it's fully extended, guys. As you can see here, it's fully extended. We are waiting for a signal at push button number 2, so that it can create this end. You see that this and this are the same. Yeah. So we still want the signal from the push button for us to release back the product. But we confirm that indeed we are fully extended. And then we want to go back with the push button. If I press the push button, this will go back and come back again. You see that? But it cannot go back until it's fully extended. Do you see that? Even if I press, you see that even if I press, it cannot go back until it's fully extended. Then it waits there. Then if I don't have this push button, it keeps on going back and forth. Covered a lot of scenarios now. A lot of scenarios. Okay. This was just a repeater and a stamp to this. We qualify now to be examined or assessed. So let's go to, how do I go to my tests? OneDrive. Let me just sign in quickly onto my OneDrive. You can attempt to do this while I search for, just to explore Ghana FUJ. Perhaps. We usually do this under left 2, guys. That's why you see left test 2. But it was not giving an inspiration in a way. It makes sense when you start with the pneumatics and end with the okay. There's so much stuff going on. Okay? So now, last question. It needs to be possible to open an electro-pneumatically driven sliding door from 2 different rooms using beam reflection sensors to and from hospital's casualty ward. See now, questions are if that thing. So let me repeat again. It needs to be possible to open, yeah, the sliding door from 2 different rooms. From 2 different rooms. Meaning that there is a sliding door here. I need to be able to press, go out. Another person from that end needs to be able to press and go in. Like how you do in a hospital or in a lab. So, and then we are using what? A reflection sensor. Yeah? So using a reflection sensor. So reflection sensor could be one of these babies. Yeah? You calibrate them based on distance. Yeah? Then once a person comes closer, much closer, they trigger a signal, then they open. Yeah? So looking at how these doors open at the mall and closes, there's no way they are operated by motor. Looking at how they are operating, even in trains and buses, we don't use electric doors. We use pneumatically operated doors. But I'm not fully sure about the ones in the mall. I've never downloaded their schematic diagram to see which components are used there. But looking at how they can reduce the speed, I know they are pneumatically controlled. Motors, although there are motors that are much smarter that they can do that from first to, but I feel like the fact that I say it's smarter, while you can do it with pneumatics, I think, yeah, it would make sense to just use pneumatics. Because anything smart comes with a price. The sliding door needs to remain closed for privacy and safety reasons. The sliding door, okay, it must always remain closed. Okay, so basically it sounds like it must close by itself. Yeah. The sliding door is opened by either the inside beam reflection sensor or the outside beam. Either or, basically. Yeah? The one inside or the one outside. Similar cases in the mall. Okay? And then it closes automatically after 5 seconds. Why timers? Hey, no. I don't teach timers. No, I don't teach timers. What happened last year? No. Let's leave this question on. Timers, no. You guys are not teaching timers. Not this year. Let's look for another test. Otherwise, you're going to faint. We check the memo. How was it? What led me to timers? Yo, but the timing is easy. Yes. Less than an hour. Yeah. The timers are easy, guys. When I look at the memo, alright, let's do it. Let's do it. It's an easy test. I didn't realize I was panicking. So let's continue. The timer. Let's do the timers. Let's do the timers. I was like, yo, devastated. You know, I'm one person who doesn't cram anything. So no, let's go back to the test. It's actually good. It's a good test. And then if you there's nothing here. When I look at the memo, it's very stupid actually. But yeah, the approach, the sound, the volume looks like something complicated. I closed my. What did I close my OneDrive? What is the question? I closed my OneDrive. Let me open it again. OneDrive. The reason why the test needed to be this difficult is because the guys they had the privilege of seeing previous questions and I ended up not having anything to ask them but to be this creative. But yeah, let me not reveal too much to you guys so that you don't faint. I have to be creative again and then I don't want to be creative this year. I want to be basic as far as possible. So, oh, it remembers. That's why I love opening stuff through OneDrive. It doesn't forget. So the sliding door is opened by either the inside beam or the outside beam. So the OR tells you that we need an OR gate. Okay. So learn from me. Never panic when you see a complicated statement. Just try and answer it. Okay. This how do I keep this now? Press. Come on, dude. You mean they only show? Yeah. So on OR, how do I highlight? Stuff has changed. What's happening? I'm not gonna highlight anymore. I don't know what happened. My stuff just changed now all of a sudden. Okay, okay, I see. I was zooming the web page instead of my MS Office. Yeah. So the OR now is there. Okay. So any of the two doors can sense, but now, okay, any from inside or outside you can sense. We have done the thing. So now, and the door closes automatically after 5 seconds. So it closes only after 5 seconds. Okay? And then the door can only close if it has reached the open end position. Otherwise, it can open at any given position. So now, I believe this is a lab door. What is it? Is it a mall? Hospital schedule to what? Okay. So, but we have a function, we are restricting it to only open when it reaches the end. Yeah? The open end position, meaning the fully extended. Yeah? Then that's when the timer starts to kick in, then it closes. And otherwise, I believe it's also the statement, it can also open at any given position, meaning that if there's an object there, the timer must be overwritten. Yeah? The door must close in short words, in simple terms. And now once there's no object on the door must close. Okay? So that's your the beam reflector, yeah? And the opening of the door needs to be fast and very slow when it is closing. When you open, must be fast, yeah? Fast, that's the opening, and then very slow when closing. Okay? Use your normal push button to represent the beam. So you don't need to panic. You read the entire question, then you understand. I didn't teach this in class basically, but I gave them as a test. And yeah, the mechanical instinct in the students came in. They all passed. So as you can see, you needed to do what? To use this a push button to represent what? A beam. Because you need to press it manually. But you know, with these things, obviously, when they're physically, you will have to come close to it, then it will connect. Remember how the magnetic sensor connects the switch inside the proximity sensor? The same procedure, yeah. So use this relay to delay timer. So you use this relay. So everything is just the same, basically, except the relay. That's the only difference. The relay from the sensor. Okay? So I need us to go a little bit back. We are doing opening from 2 different rooms. So net, and then we don't need this. This I think is also another way to trick students. We don't need this. We can highlight this. Come on, dude, remove the highlight. Of no color, right? The sliding door needs to remain closed for privacy reasons. Okay. And then let's look at the cylinder. The picture now. Okay. The extension. The extension represents opening. The retraction represents the closing. The reason why I go back to the picture is because of it is possible. You guys did mechanical. As you can see, we're using components there. It is possible your extension, even your closed of the door, and the retraction, even the open of the door. Yeah, the pictures are there, guys. 1, 2, yeah, the pictures are there. Let me quickly check if I have them. If I don't, I might have them. The reason why I prioritize these batteries is because I've got a feedback that without the mic, the video gets to be affected, so I don't want it. Okay. Yeah. So now, as I was saying, it is possible for the retraction to represent the opening and the extension to represent the closing. All right, guys, hold on. So let's also read the rubric. The sliding door is opened with any of the two sensors. Okay, the sensors are connected to the correct function gates. Okay, so meaning the OR gate. Then the correct label on the sensor. All right, you need to correct them, label them correctly. Correct sensor type, correct configuration on the ruler. All right, correct relay on the ruler, and correct valve, correct configuration, speed control for advancing and the retracting. Okay, and then S apply and no errors, stuff like that. I used to give them 50% for errors. I'm not. For borderline, I will take 5%, yeah, of the overall mark. But these errors are not the borderline. There will be an area borderline. I'll see it by just looking at your circuit. Then there's that one whereby your wiring goes next to a certain terminal, then it doesn't want to work. I'll hold 50%, just take it, put it in my pocket, and give you 50%. Simple as that. And we are required to introduce more penalties. There will be more of them when the test comes, by the way. If you can't do this, it will be 10%. If you can't do that, 10%, 10%, 10% until you are below. You owe me marks actually, but I don't do that. I don't do that, honestly. Yeah. So I think we've covered almost everything. S1 is a proximity sensor. You must read the entire question and highlight where possible. S1 is our proximity sensor positioned at the end retracted position. End retracted, okay, it says end retracted position of the cylinder, and then it is it's only activated when the cylinder is retracted. I don't think this is right. S2, it's at the extended end position. This information doesn't sound right. And then S2, or in the event of this one here, maybe I was in a rush. I don't think this information is correct because we only had one sensor for advancing. If you read here, what are they saying? Open end position. The door can only close when it has reached the open end position. Otherwise, it can open at any given position. So if it can open at any given position, it means that we don't need the sensor that is at the retracted here. We only need this the extended positioning. So this statement, particularly for this one, it must be out. I think I might have forgot that. And then even this one, we don't measure the end positioning sensors. We must do only one so that it can be flexible. Remember, once you put these two sensors on the cylinders, it means that it needs to be fully closed, fully open. But we are saying that once it's fully closed, it can only once it's fully open, it can only close. But while it closes at any given position, because you need to walk towards it, it must always open. But in a dangerous lab, you do opposite. It must always close, yeah, something like that. So let's draw it. I think, yeah, people are now being patient with me. Why do I have switch on and switch? What is this one for? Counter. No, we don't count with delay. All right. So the basic stuff. This, you put it at the corner, and that, and that, and that, like this. Okay. For the sake of time, let's not control the speed. Okay. There, done. So now, I don't want to fly through. I'm going to take you through nicely. Our that copy paste, right click and 180. Okay. Then that. My eyes are becoming impatient with me. Oh, prof, I thought my students were waiting to enter from outside. Okay, no problem.
Morning, class. Yeah, just quick, your indulgence, 1 minute. I won't be long. I need you guys. Are the kids set for that text? After the class.
Yeah.
So after the class, you're going to fetch your Arduino kits. We just need one representative from the group. You tick your name and you sign. We've got the 35 groups right here. There is one particular group 35. One of the students' details is not here, so I'll need you to put it down your details. Duat and is it Zwat and Tabete, you are in group 35. So there is one more group member that is going to be 35. Just add your details. Um, for those that are doing PJ MMIB3, I will connect with you later in the day. Yeah, because I'm very busy with departmental stuff now. I can't do the normal consultation. So if you have questions, you just meet me during the class. Yeah, thank you.
Okay.
Yeah.
Thank you, sir. We're gonna give you the entire kit for wait. Arjunas. With me. To me. Yep, to come here. So we'll fetch it. I think that's at 11:08. That's where they are positioned. So from here we can just go straight there, and then I'll hand them out to you guys. We'll give you the entire kit. We normally ask students to pre-select components and then go with them the ones that they need. But we realize that it doesn't work properly. When you return them, there's always a mix-up. So we're gonna give you the entire box. Treat it like it's your own. Don't be shy. Tell us, Nick, I broke something. I won't say replace it, but don't aim to break anything, because I'll make you pay. But yeah, so the aim is if we give you the entire box and there are any shortages, because the cables sometimes you need to amend them, for instance, like to compile and cut and stuff like that. Maybe just let me know, Nick, I wanna break something a little bit so that it can do this and that. And then we keep record of the stuff that are either missing. Even if you go to the box, something is missing, something is not working, let me know. I'll keep it in record. The aim is what we did last year, because we handed over what we needed, then there was a mix-up. So now we want you guys to help us to kind of know what is missing in each box so that we can replace them ourselves, not you. Yeah, so we want to refill, but we don't know where to start, basically. But with you guys, we know that you'll be working with this. Maybe you need a motor or something. We can try and organize purchasing it. But you must know that the usual buying process is very long. But yeah, please help us on that regard. Okay, so before I waste any time, let's dig into this question. We have two push buttons, again, that are connected in parallel. The one inside, the one outside. Okay, I'm not going to label them. And then we have their relay. We're not latching on the electrical side. Yeah? The latching, we're going to rely on the 5-2-way to latch. So this is R0. Okay? And that R0. Now we're actuating. Now we are actuating. Yes. Sol 0 and the changeover. And I think I've opened a lot of stuff. They tend to confuse me. No, relays, I need them. Change over like that. You'll be surprised how stupidly easy this test was, but it was just buried under some unnecessary statements. Sol _0. Can you believe this circuit like this is complete when it comes to extending? Sol _0. Start. Extend. The door opens. You walk towards it. It opens. Then retract. Another one. Oh, I did this one. Then simple. Do you see? That's a basic circuit for extension, but in the form of an OR gate. But it was under some rubble of statements that pulls your leg. Okay, then now we set the the return must happen by a proximity sensor. Then, sensor which is positioned where? Where is my? Yes. Okay. Sensor that is positioned today. Ne? We'll call it S1. There's no need for this one to be S2. It's S1. Okay. At the end, okay, it returns automatically after 5 seconds. So let's do that basically. So that sensor, it's a proximity sensor. And also, yeah, I wanted to say this. You cannot put these sensors here. It must be wrapped around the cylinder. You understand? This is one of the typical examples. You must wrap them around. Otherwise, the sensors will be visible basically to everyone, and they will possibly risk to be taken. And also, when the cylinder, is connected, it has a end rod connected on it, and yeah, so as it extends, it will hit those stuff. So you're gonna have a complicated situation. Use proximity sensors. So now, proximity sensors, this is the one. And I'll just, no, not the counter, but the timer delay, like this. And changeover switch. Solve, copy paste. Oh, so where it goes? What is wrong here? This one is mistaken. Let me go. Okay. We can just say TR1. Although there's a thing, a 5 seconds delay, you can't. On more advanced softwares, on the fully licensed one, you can extend the timer here. Then R1. Can you believe this circuit is complete, guys? Can you believe that? So, but I'm gonna test you. What is missing? What is missing? The ruler. Yes. Only the ruler is missing now. So, one. No, not so. It's not so. It's proximity. So it's going to P0. It's the first one again. The first one, P0. Then 100 or 0. Okay. P0. Right? Watch carefully. Put the timer there. Then activates. So one. What's missing? Troubleshooting. You see? What's missing? Labeling. You didn't label the site.
So what type of switch is the one on the last?
No, the normal changeover switch, but because of it works with a timer. Let's remove it. Let's amend it. Let's say going to make it 0. Just check. You see, it's a normal one, but because of we are putting a relay with a timer, then it amends it. Okay, then time. Timer goes, and I like the fact that it starts from 5, 4, 3, 2, 1, then it returns. Then obviously we adjust the speeds. Which speed is much more favorable? The closing speed or the opening speed? The opening. Yeah. It must be faster. And then the closing must be slower. So that even if it doesn't pick up your puppy, it mustn't crash it. But because of it's a public door, I would strongly recommend you use both speed controllers. Yes, sir. Sorry? If you want your door to open with retraction, you will assume that as it's retracted right now, it's closed. Yeah? So meaning that the cylinder, wait. Let's go to the picture. Let's go to the picture. Right. We take this cylinder, put it the opposite. Yeah? And then once the system is retracted, yeah, the door will be open. And then once it's extended, the door will be here. But now there's a strain on the system because it needs to be actuated and remain like that. Like the cylinder will need to be like, once it's at its advanced position, then it tends to be a bit of a problem in terms of it's easier once it's on its comfortable zone, meaning that since when the door, most of the time it will remain closed, né? Then it's easier to also remain the cylinder retracted. Then once you open, it's a once-off thing. Remember, unfortunately, you guys are not taught reliability, or FMEA and stuff like that. As a mechanical engineer, you need that course. If you can find it somewhere, go get it. I beg you. Reliability. You'll be learning the failure mode effect, whereby you analyze how you know these things, man. They say the motor runs for 10 hours. You know that terminology. Something runs for 25,000 hours. Even a bug is the lifespan of every product. Those basics, you need to know them. So that once you buy now, you know I'm buying a public door. It's not like in the case of in a laboratory, whereby maybe the door needs to remain open and closed once a certain condition is actuated or whatever. So such things you need to like your tensile strength calculations are taken with a okay, not calculation, experiments. Let's say you're doing a tensile strength of a certain material. One want to choose maybe a body of this thing. Maybe you're analyzing the plastics. You put that onto a reliability software. It will tell you it's the force required to break it and stuff like that. How long it will last and stuff like that. Reliability is more of a statistical stuff for experiments. When you're doing experiments, and you guys will do design, some of you. Most of you will be on maintenance and sales engineering and stuff like that, but those will be lucky to do design. Actually, let's just say all of you do reliability. Just find a way. It's normally taught by the guys for MPhil, but I wouldn't say go to do MPhil after your honors. No. Just get a course on Coursera, Udemy, MOOCs, anyway. LinkedIn, whatever. Just get a certified course and do reliability. You need it as a mechanical engineer. The stuff that I saw there, we are given data analyzed through the reliability analytics. Yeah? But we don't really care about how you guys develop that data. Imagine if you develop the data by measuring something, different thicknesses, different temperatures and stuff like that. Then you yourself put it in the system and you get results. And then you go to pitch that to maybe your boss to say, there's no, like right now, the BMW iX, something like that, iX7, the one that can change color. Do you know that there's a electrical car that can change color? One of the things that it can do, it can self-heal when it has scratches. What is the material used on that car, on the panels? Who knows? Material, the panels. Are they still aluminum or what? The plastic. Well, what's your reviews on that car? Imagine, now we're driving cars with plastic panels. And this thing of plastic started a long time. The carbon fiber, that's plastic basically in a way. You've been seeing your not Aston Martin. Which one is this? The McLarens, the Bugatti, stuff like that. Most of their panels, they are actually plastic. And they're on the road, and they're safer than the ones that comes with the screen. You see now. So obviously, it took a very intelligent mechanical engineer, particularly, to discover that these materials are lightweight, they're stronger, they can last longer. It took you guys basically when you're doing your reliability studies. That's why reliability is one of the courses that I really want to emphasize to students. Unfortunately, I can't teach it, I'm not accredited to teach, but it's close to heart for you guys. I beg you, for your own good, go learn it. So guys, this is roughly what you're going to meet in the test. I did this myself, created the question from scratch, but when I read it 1 year later, yeah, it trapped me as well. Sorry, man. Sorry. He explained physically what I felt when I read the question. My own question. Imagine, my own question. You know, I was like, no, we didn't do this. So don't be afraid. Break down the question by highlighting critical information. You hear me? I like only critical information. That they say the door needs to remain closed. I could say, hey, the door must remain open. I could say, according to this guy, the extending is the closing or is the opening. You know, I could say any of those things. But the beauty is that I don't just create a test and I test it thoroughly and see. But sometimes I miss the typing because at times you have this idea in your mind but you can't put it into words. And that's why a bit of managerial courses is very critical for you guys. I'm not sure if you've done any. You need them. These are the conversations that you don't normally have with the mechanical gurus. They're only concerned about designing stuff and calculating stuff. But you must know that in the reality, we deal with politicians in industry, mostly. And when something is politically correct, it doesn't mean it's mathematically correct. And now you need to be able to justify, you need to build your confidence, your presentation skills. As a science engineer, you can't start at there. You need to convince, you need to know your story. And also read books, guys, as well. Don't read inside the heart. Our imaginary voice can read anything. Do you know that? Do not, you must read it aloud, and preferably read it when you are home, and read as if you are still learning to talk. It helps to read. It helps to with the presentation skills. But otherwise, guys, next week we are writing on Friday at the same time, 9:40. I won't make it difficult, and I want you to all pass. How was the first lab entirely by teaching and stuff like that? Was it bad? No, the entire lab one before we get to our test. How's my presentation skill? How do I deliver the course?
Yeah, When
Yeah.
you were teaching as if we knew, but then we had to
Yeah.
give better answers. But in the first place, we were just shocked at how to translate.
I'm of the view that you did electro technology, electro tech too.
Yeah, but not like this. Yo, I don't remember what not like this. Yeah.
Sorry? Oh yeah. Okay, I see. Okay. Uh, but yes.
Also, okay, I know that sometimes, most times, it's our responsibility to actually look up what each and every component that we see displayed does. But sometimes, okay, let's say with the first lesson or the first lab, just to give us a broad spectrum of the ones that are commonly used in the entire circuit itself. And this is what the proximity sensor looks like. It does this. The relay, the delay relay does this. The valve does this. So there's actuators. Just like you did with the different actuators.
Yeah.
So just like the complex ones that are going to be commonly used in robotics, those ones.
Okay. So far, I don't change much. Then it's only the English that changes. But every circuit we have done, you can almost get it as it is. Remember, when you look at the circuit, remember with the previous one that we did, originally, we were supposed to start it, it goes back and forth. And I said, I want to add a push button that will be connected as an OR. Yeah? Then now we could return it at any given position as it does the up and down. And then you can also test the one whereby we had two push buttons now that says once it's extended, it must remain there until you press the push button. I don't think I can come up with something different from what I've explored. Remember, they gave us one scenario, but we've turned it into three scenarios. See now, so we've answered it in three different ways. So for me doing that, I'm triggering your capability of you. Maybe let's say when you're studying, you now start to test different scenarios. Once you are capable of testing different scenarios by yourself that are in line with what we are doing, it's 100 for you, basically. I want that you. And I always say the double pilot is almost always going to be there, and double acting cylinder always going to be there. And then earlier on, before we started the lesson, I said we're only gonna sense one position. Get even this case, we sense at one position, isn't it? And as I said, we're going to control the speed of the motor only in one direction, either when extending or when retracting. And then I said, if we use both of them, you can cheat basically. You don't really see, but it's much more juicy when you understand. When I want to set the speed for retracting, this is what I do. For extending, this is what I do. I don't do too much of because you saw the exercise 10, they talk about pressure sensors and stuff like that. I don't normally go to that level, but there are something if you are out of interest, you want to explore further, you can come and I give you those answers going forward. Then you go DIY for yourself because they are very important. There are times whereby you are using the cylinder to maybe stamp items, yeah, boxes. We are stamping them, or maybe we are marking them. So, or maybe we are picking them. So now, but the height, actually, there's a cylinder I'll show you now that has an extraction cap on them. There's a cylinder on factory O that has an extraction cap. So what it does is it extends, then it starts to suck, then it picks up an item. So once the force is equal, then the box height are not equal. What will happen? When the taller boxes comes in, it's going to crush them. You understand? Then on these questions from that one going from I think 10 going forward, they do cover a question whereby you kind of take a box, you compress it, and then you check what is the max required pressure to crush a box of any height, basically. Then you get the standard, maybe let's say 2 amps, not amps, no. What if 2 bars can crush the box? So I'm gonna do 1.5 for safety reasons, because when you extend, you can easily crush the box sometimes. So now what we will do is, as it extends, if it feels that pressure of the resisting pressure of maybe the 1.5, it needs to stop and start the suction and go up. Because cylinders can vary. In our case, we are looking at small cylinders that you can't really explore those scenarios. But once you come into a software similar to this one, let's do scenes. No, not scenes. New. I want to show you now just a simple. This one. Look at this machine. So let's say maybe it has to take products here. Okay, then let me take a box. So these boxes that they differ in height, you see that? Okay. Not getting my best angle. Okay. Like that, right? And like that. Okay. Hopefully, you will be able to extend until. So this is like your extraction cup, it sucks, suction cup, and then this is your cylinder arm. So hopefully it can extend. You see how long it is. So once I press play, and I come here. Okay, then I want to see which one is extraction. Z position. So I'm going to activate this one. Activate. So unfortunately the height doesn't allow me, but on the conveyor belt, should I put a conveyor belt, it would be able to reach it. So you see it can extend. Then after that, it starts to suck. Okay, let's redo this with the proper way. I thought it was long enough. It's not a problem. It can go far. Let's get the conveyor. Which one? This one. Right, let's turn around. This software requires gymnastics, guys. From next week, they're doing the software. Hey, no, where did you go? Okay, let's leave that box. Let me get another one. I lost that box. Love this software, guys, with all my heart. And accuracy in the software is very critical because you can see almost any angle you want. So, like for instance, I can see, okay, right, something like that. Play and okay. So, in a real life machinery, this box could be crushed. You understand? If the cylinder is not fully extended, it will be crushed. So because of the boxes they differ in height, you can now put a pressure regulator to say once we reach this maximum pressure, do not extend further. Just start the suction and go back. Then I'll activate the suction and I'll go back. You see it takes it down. You see that? So then maybe then after that you will then extend and place it somewhere else. Let's see if I can extend. Let's see. Extend. See, it's extending. and I want to go down. Which one is that? Okay, I go down and I release the box. Then I go back to my positioning. So you need to be able to do the pressure regulator. And the pressure regulator, I love it because it's under the PLCs, it's under analogs. I'll teach you introductory to analogs, and you'll see, you will explore by yourself onto doing the pressure regulators. So then I strongly encourage that you DIY going forward to gain more knowledge into these things, because you might find yourself working with them. The chances are much higher than the industrial guys, because South African industries don't regard industrial engineering as people can do automation for some various reasons, and one of them is that they don't have a background of hands-on and a lot of calculations like you guys have. You know, our students can only design most of the time, like the basic circuits only. But you guys who can design, build, do calculations and stuff like that, you are more like your background allows you to be more intuitive. And most of the time, even the departments also, they don't, industrials background are lean management and stuff like that. You guys are more hands-on. If you are lucky enough to work under a guy who does instrumentation, you'll be exposed to such stuff. Mechatronics, you'll be exposed to such stuff. You don't necessarily need a qualification in mechatronics to start working with these things. No, I've seen it. There are guys out there for mechanical who are dealing with PLCs, dealing with pneumatics, hydraulics, and stuff like that. So I am confident that one of you, or even quite a big number, a chunk of you guys, might find yourselves working with these things. Okay. Come and consult game. I'm tired now. Yeah. So guys, thank you so much. You've been a lovely audience.